Example 3. Radio detection finders are placed at points A and B, which are 3.46 miles apart on an east-west line with A west of B. From point A, the bearing of a certain radio transmitter is 47.7 degrees, and from point B, the bearing is 302.5 degrees. Find the distance, rounded to the nearest hundredth, of the transmitter from point A. All right, make sure you read through this question and understand what is going on before you begin. Okay, we have to draw this situation out. Okay, so obviously we have 2 points A and B that are located along an east-west line, and there's also some kind of radio transmitter involved. Okay, so here we go. I am going to begin by drawing this east-west line, okay, with A and B on the east-west line. Okay, so here comes my east-west line. So it's going to look just something like this. And I'm going to go ahead and put the 2 points on here, A and B. Okay, and we know that A is west of B, so A has to be to the left of B. So here's A, and then we'll say here's B. Okay, and then there's some kind of radio transmitter out there. So let's focus on, we have some bearings involved. We have 2 bearings, and so let's focus on A first. It says radio detection finders are placed at points A and B, which are 3.46 miles apart. Okay, so let's go ahead and put that information on there because we haven't done that yet. So the distance between these 2 points is going to be 3.46 miles. Okay, so we know that. And now it says from A, the bearing of a certain radio transmitter is 47.7 degrees. Okay, so let's deal with that. Okay, so from A, the bearing of the radio transmitter is this. Okay, so at point A, the bearing is given just as an angle. So we've got to set up our cross here. Okay, so here is basically the little west and east, and then I have to put in my north-south line. Okay, since the angle is given for bearing, that means that it is relative to due north. Okay, so let me see if I can position this just a little straighter here. Okay, so here's my north-south line through this point A. Okay, so like this, north-south. And let's go ahead and draw in the bearing. Okay, so basically if we align ourselves with due north, we are going to go in a clockwise direction by 47.7 degrees. Okay, so you're going to have to eyeball this. This is about 45 degrees. Okay, so bisecting the right angle, so just a little more. We'll go ahead and say right there. Okay, so let's say here's the radio transmitter. Okay, so this is the transmitter. That's what this is. Okay, and this angle from due north to this black line is going to be 47.7 degrees. Okay. All right, so that's all we really get out of the yellow statement. So what else we can label in this picture is the bearing based on B. Okay, so from B, the bearing of the transmitter is 302.5 degrees. Okay, so we're going to have to set up another little direction thingy here. Okay, so here's our east-west line, and then we'll have to put in a north-south line through B. Okay, so it's going to look like this. All right. So here we go. North, south, west, east. Okay. So again, when you look at this bearing for B, okay, it is an angle. So you have to begin by aligning yourself with due north. Okay, and then you're rotating clockwise 302.5 degrees. Okay, so if we go all the way around and we end up at due west, that's 270 degrees. So we have to go more, but remember in our drawing, these angles are not exact, but you have to end up at the transmitter. Okay, so it's looking like this, it's forming this oblique triangle. Okay, and here is the bearing. If we start at due north and we go all the way around to right here, that's the angle that's 302.5 degrees. Okay, so this is how it needs to be drawn. Okay, and we're assuming, because we're in these two sections, that this is an oblique triangle, but we do have to go through the work to make sure there's no right angle involved. But this is the picture. We have gathered all of the information in the problem and translated it into an illustration. Okay, and that's what we're going to work from. Moving forward, what do we need to find? Well, the last statement says find the distance of the transmitter from A. Okay, so you're going to be finding this side right here. Okay, so yes, I drew the transmitter as a box, but remember, it's really, for our purposes, just a dot. Okay, it's located at this top vertex of the triangle. Okay, so we're trying to find this green distance rounded to the nearest hundredth. Okay, all right, so let's do some work here. Like I said, we have a triangle involved. We don't know any of the interior angles of the triangle, but we can do that based on the information that we've been given. So if we start with point A, we know that when we drew in the north-south line and the east-west line, that those guys are perpendicular. So this is a right angle right here. That should measure 90 degrees. And we know this angle, this 90-degree angle, can be broken up into two angles. One, this 47.7 degree angle, and then this other angle right here. Okay, so we can figure out the measure of this green angle by taking 90 degrees and subtracting 47.7 degrees. So let's see what that gives us. 90 degrees minus 47.7 is going to give us 42.3 degrees. Okay, so that's the measure of this angle. So now we have one of the interior angles of the triangle. Okay, we can use the bearing at B to figure out this particular angle right here. Okay, this red angle. Okay, we know that if we align ourselves with due north, we start there and we go all the way around to this line. If you can see where my cursor is, that's 302.5 degrees. Okay, but I know if I start here and I go all the way around through three of the quadrants, that's 270 degrees. So if I take 302.5 and I subtract 270 out of here, that's going to give me this red angle. Okay, so if I do 302.5 minus 270, that's going to leave me with a 32.5 degree angle. Okay, so I can label this inside the triangle. Okay, so this is our second interior angle, and now we can get the third angle because we know that the angles inside of a triangle have to add up to 180. So I'll go ahead and use a different color here. Okay, so it'll stand out a little bit more. If we want this angle right here, okay, we just have to subtract from 180, take 180 degrees, subtract out the 42.3 degree angle, and then subtract out the 32.5 degree angle, and then we'll get the measure of this orange angle. Okay, so we're going to do 180 minus 42.3 minus 32.5. The orange angle measures 105.2 degrees. Okay, so that kind of verifies that this is an oblique triangle. It is not a right triangle. All right, so now we need to figure out what case this is. Okay, so that will tell us whether we need to use the law of sines or the law of cosines here. Okay, so we know we're looking for this green side length. Okay, I'm going to go ahead and label things. We already have like A and B as our points. So the third vertex of the triangle, I'm going to call that point C, where the transmitter is. That way I can go ahead and say, okay, if I'm going across from angle C, this is going to be side C. If I'm going across from angle A, and we're going to call this green angle A right here, this is point A, this is going to be angle A. If we go straight across from angle A, this is going to be side length A. And then angle B is this red angle. If we go across from that guy, this green side that we're looking for is going to be side length B. Okay, that way it's easier to translate into the law of sines or the law of cosines. Okay, All right, so like I said, we are looking for side length B, but luckily we know the measure of angle B is 32.5 degrees. Okay, so that's good to know. So let's figure out what we know and go from there. Okay, so we know the length of side C. Okay, remember the distance between point A and point B is 3.46 miles. So we can go ahead and say this is 3.46. Okay, so we know this side length. We know this angle. We know all of the angles, which is good. So because of that, I can look at this and say, I know, I'm trying to pick a color that I have not used here. Let's do blue. I know an angle, a side, and an angle. Okay, so let's go ahead and say this is angle, side, angle. Okay, because I know an angle, I know angle A, the side next to it, which is side C, and then I know angle B. Okay, so this is an angle, side, angle case. Okay, angle, side, angle is not sides, it's not SAS, so we need to use the law of sines here. Okay, all right, so we need to figure out which of the equations we need to pair together. So if you go back to page 2, we know that there are 3 separate equations for the law of sines. Okay, remember, we're interested in finding side B, so at some point we're going to have to involve sine B over B. But if we look at this, we know angle C and we know side length C. So we need to begin by using that. Okay, so sine of C over C is equal to, luckily we know something about B, so we can go ahead and use B. Okay, we know angle B. Okay, so when we set it up this way, this is going to be the only unknown. Okay, and I guess I should have put that in green. Okay, that's going to be our only unknown because we know sine, we know the C angle, we know the C length, we know the B angle. So we can use this equation to solve. Okay, could we have used sine A over A? Like, let me restate this. Could we have done this? Sine of A over A is equal to sine of B over B. Okay, well, again, this is what you're solving for. It's an unknown. We know angle A, so sine of A would be okay. However, we don't know side length A. So you wouldn't want to go this route because then you would have 2 unknowns. Okay, you need to know 3 of the quantities and just have 1 unknown in order to set up your equation. Okay, also you wouldn't have wanted to go this way because it would have been extra work. Okay, you could actually go this route because you know angle C, you know angle A, and you know lowercase c, and you could have solved for lowercase a, but that's more work because then once you have lowercase a, you'd have to go get lowercase b. Okay, so the most direct way to solve this problem is through law of sines in setting up this particular equation. Sine of angle C over side length C is equal to the sine of angle B over side length B. Okay, let's go ahead and plug into this. Okay, so we know this is going to give us the sine of angle C, that's 105.2 degrees, over side length C, that's 3.46. That's got to equal the sine of B. Angle B is 32.5 degrees over our unknown B. Okay, so we have one fraction equal to another, so we need to cross multiply. Okay, so this times this has to equal this times this. Okay, so we're going to get that B times the sine of 105.2 degrees has to equal 3.46 times the sine of 32.5 degrees. Okay, the sine of 105.2 degrees is just a number. Everything on the right is just a number, 3.46 times the sine of 32.5. So if you want to solve it for B, you just need to divide off the number that it's being multiplied by. Okay, so let me write all of this out for you. Okay, so we're going to go ahead and divide both sides by the sine of 105.2 degrees. Okay, on the left side, the signs will cancel, leaving you with B. Okay, so I'm going to go to my calculator and I'm going to punch this in. Okay, make sure you're in degree mode when you're doing this. Okay, so we're going to have 3.46 times the sine of 32.5 degrees. And then we need to divide that by the sine of 105.2. Okay, and then this is going to be the decimal for side length B. Okay, so we're going to get 1.92 6450642. Okay, this is a side length. Okay, we need to go ahead and round it according to the directions. The directions say round to the nearest hundredth, okay, which is 2 places after the decimal point. So after the decimal point, we've got 92. There's a 6 that comes after, so we need to bump up to 0.93. Okay, so the side length B that we're looking for, we can go ahead and say that's approximately 1.93, and we need to put units on it. This is a distance. Distance is being measured in miles here. Okay, so here is your answer. This is the distance from point A to the transmitter.